Welcome, my name is Brian Nelson. This is the third lesson in the Introduction to Programming with C# course. In this lesson, we're going to introduce variables, constants, operators, and arrays. Let's get started. One of the most fundamental aspects of computer programs is being able to store a number and perform an operation on it. An operation might be addition, subtraction, multiplication, or division. In a program, values are stored in variables. The name variable means that the value can be changed during the execution of the program. Values can also be stored as constants. A constant is a value that is defined in the code and does not change during the execution of the program. An example of a constant is the mathematical value of pi. Using constants protects the values from being accidentally changed by invalid code. We wouldn't want the value of pi to be accidentally changed during the execution of our program. A variable or a constant is defined with a name, the type of data in it, and the value that it is. A variable name should generally be descriptive. I try to keep variable names between 5 and 15 characters in length. A variable name might be gallons of fuel or number of wheels. Simple counters can be defined as a single letter like IJK or XYZ. For this introductory course, I'm only going to focus on 4 of the most used types of variables. Those are integers, doubles, booleans, and strings. There are many other types that will be more fully described later in a more advanced course. An integer is a number without a fractional portion, like 1, 2, or 3. They are often used for counting or for a value that will never have a fraction. An example of this might be the number of wheels on a vehicle. A double is a number that allows for a fractional portion. The mathematical value of pi, 3.14159, could be stored as a double. If you wanted to calculate an average, a double would allow you to track the fractional portion of that number. A double is a type of floating point value, where the number of decimal points available changes based on the value being stored. A double can generally only store 15 digits before data is lost. This can sometimes cause issues with lost accuracy. For the purposes of this course, that's not going to be an issue, and we're going to ignore this. A Boolean variable allows a programmer to track true or false values. A Boolean might be used to track if a light bulb was on or off. The programmer might define a variable as isOn and set it to true or false. The last variable type we are going to investigate is strings. A string is a variable that is able to store a sequence of characters. You might use a string to store a descriptive name of the color of a vehicle, like red or blue. Strings are immutable. This means that the value of them can't be changed. If you try to change the value of a string, a new string is defined each time. This can have serious impacts to performance if a string is created and assigned in a loop. We will look at a way around this performance impact in Lesson 9 of this course. So let's go take a look at variables and constants in Visual Studio. So I've set up a Lesson 3 that is a copy of where we left Lesson 2. So if you're going to go download the code from Git, you can see each lesson as we progress. Otherwise, if you're going to continue on, you can just do it in your existing lesson. So either way you want to work is fine. So I'm going to go ahead and delete this hello world. You'll notice static void main, and then our string array of args. And then we have an open curly brace and a closed curly brace. Now our code, so we're going to create an integer, int hour, and we put a semicolon at the end of the line. So that tells the compiler this line's complete. Now, we've defined the variable, but we haven't given it a value. So let's give it a value. So what we can say is int hour equals 0. Okay, so that's all that is needed to define an integer. So an integer, we can give it a value of 1, you can give it a value of 2. So any whole number, what you can't do is 3.5. So the compiler will tell you, okay, there's a problem here. Cannot convert a double to an int. And I was able to get to that just by hovering over the red squiggle line. You can see if I hover over the green squiggle line, it's telling me that I've defined a variable that I've never used. And so the green are like recommendations, but obviously as you're writing a program, you're going to define a variable and use it later. That's not a problem. It's the red ones that are going to be a problem. And if I were to try to run this right now, it's going to tell me that there were build errors, and it will let me run the last successful build, but I haven't ever done that. There's no point. No, I don't want to run it. And so down at the bottom, the error list comes up, and you can see the red X tells me that I cannot implicitly convert the type from double to integer. There's also a warning, so one error, one warning, that the variable hour is never used. Now, if we don't care about warnings, we can turn those off, or you can turn them on. You can hide the errors. So you're able to use this window to kind of track down what's most critical to work on. So, okay, so obviously that's not going to work. So we're going to just set the hour to 0. And then, so our second type of variable that we're going to look at is doubles. Double temperature. Now, that's the simplest definition we can do. We can also assign it to a value. Now, if we want, you can assign an integer to a double. That's okay, because basically an integer itself can't accept decimal values. A double can accept either integers or decimal values. So that conversion is automatic. Now we can also do 0.0 and be much more explicit with it. The third type we want to go over is a Boolean. So that is bool is hot day. And so that's the minimal definition there. Or we can set it to true, or we can set it to false. So that's a Boolean. And then the next type we were going over was strings. So we can define string description. And that's the minimal definition. So we have the data type and then the name of the variable. And let's say a nice day. So there's the 4 different data types that we're dealing with for this course. Now, the next thing we introduced was constants. So if we wanted to say, let's create a constant hours in day. Okay. Now, it's not happy because I haven't given it a data type. So we can have constant integer hours in a day. Now, it's still not happy, where before it would have just said green, you have not, we've defined a variable that we haven't used. It has to have a value assigned to it. So hours in a day equal 24. And we're going to ignore daylight savings and all leap days and all that kind of stuff. So we have 24 hours in a day. Now it's happy, or at least it's green. We've defined a variable. Okay, we've defined a constant, but we haven't used it, so that's why it's still green. So let's go ahead, and I'm going to put a breakpoint here, and we're going to run this. We're going to debug it, and so it will start. Okay, so you can see that we're setting up all these variables. Now, if we look down here, and these windows are all adjustable, so if I click here, I can drag that up. So you can see that the variables in this block of code, and basically what the locals mean is the values in the current method. We'll come back to defining methods and procedures and that kind of stuff. But basically, these are the values that are defined in this block of code. and you can see what they are. Now, let's go ahead and I'm going to stop this with the square. What we can now do is we can now say hour equals 1. And then we can say hour equals 2. So we're assigning an hour to a value of 1 and then the variable hour to a value of 2. Now, if we try to say hours in a day and we want to say, oh, there's 25. Because we have defined this as a constant, we cannot redefine it, okay? So if we got rid of the constant, then the compiler will be happy and we can change that. I'm going to undo because I want to leave that as a constant. So we can't make that change. So that's not a good line of code. So let's go ahead and debug this again. And we're going to step through, and you can notice right now hour is 0. And so you can see as it changes, hour equals 1, and now hour equals 2. So this is how the local variables are very helpful in when debugging a problem. You can watch and see the values move as you execute the lines of code. And that is really helpful for finding where you have problems. As you get more and more complicated programs, sometimes it gets very hard to figure out where the problems are. So we'll go ahead and continue. The program completes. And you can see there's now a new warning that hour is assigned and the value is never used. What the compiler is trying to do is say you're doing extra work that isn't helping. Because there's no code between these lines using the variable hour, the computer is saying you're just wasting CPU cycles. And that's performance, and that equates to real time at some point. In our case, this wouldn't be very bad time loss, but the idea is to keep your code as clean as possible. So I'm going to go ahead and hide these warnings because they're not really helpful as we're learning. And we can come back as we do some more advanced debugging and turn that back on. Let's go ahead and also show an example of changing. So if we want to change our temperature, let's say it's a warm 90 degrees, we can do that. Let's say the hour, okay, so it's 90 degrees, and I'm going to edit this and set the hour. So at 10 o'clock, it's 90 degrees. So it's a warm day, and definitely is hot equal true. So we're going to set that. So this is an example of how you can change values programmatically. And then we can run that and just verify that the hours change. So if we go F10 to go to the next statement, it is now a hot day, the temperature is 90, and the hour is 10 o'clock. Now that we know how to define variables and constants and store a value in them, we want to be able to act on these values. To do this, we use operators. Basic math operators like addition, subtraction, multiplication, and division are possible. There are also many more. .NET also has a library of mathematical functions that can be used to perform advanced operations. Let's now take a look at working with the variables that we have set up in Visual Studio. Okay, so now we're going to look at operators, and operators allow you to act on variables. And so the typical operators are addition, subtraction, multiplication, and division. Those are the main four for integers and doubles. You can do some string concatenation. Concatenation means to combine two strings. We'll take a look at that. And those are the kind of the main ones that you might do, at least at the beginning. So let's see. If we just want to define, say we're doing just some basic algebra. And so we're going to define integer x, and we're going to say integer x is 10. We're going to define integer y and say y is 8. And then we're going to say int value equals x times y. Okay, and so that's a basic multiplication. Let's show you one other thing. So if you go and you hit this That is the comment out a section of code. And then we can uncomment the code. So you notice there's 2 slashes. That is commenting out a single line of code. If we uncomment all this, we can also comment out multiple /* and then */. This structure is commenting out a block of code. And I'm going to undo that because it's easier to just comment out this block. Integer x equals 10, integer y equals 8. So what that lets us do, commenting out this block, is we're going to just skip that code. And when we debug, this will be the first line of code. Okay, so right now you notice x is 0, y is 0. They've been defined, and now they've been assigned values. And so 10 times 8, we're going to expect a value of 80. Okay, and so we get a value of 80. That's great. Let's go ahead and stop this. Now what we can do is, let's say int value 2 equals value divided by 2. So 80 divided by 2, we're going to expect 40. Let's also do int value 3 equals value divided by 3. Now, if we bring up our calculator and do 80 divided by 3, we're going to get 26.667. Okay, now that's not an integer. So what's going to happen? We've got an int. We're going to do value divided by 3. Our integer can't store that data. So let's take a look at what we get. So we're going to debug. I'm just going to hit F10. That'll start the debugger, put us on the first line. So there is our value, 10 times 8, 80. Value 2, that's great, that's a 40. Value 3 is 26. So what happened is it just truncated that data it couldn't store. So you can still do arithmetic with integers that ends up in fractions, it just loses data. Say we wanted to get that data. So let's do double value, and I'm going to call it D3 or double 3 equals value divided by 3. And so I'm going to move my breakpoint. So basically, by moving the breakpoint, it'll kind of run those lines of code and stop me right there. So let's go ahead and do that. So it stops me. You can see we've already done the prior calculations. We hit the breakpoint. Let's run that line. Now this is potentially confusing because we have just done value divided by 3. We've defined it as a double, and you notice down here we have a value of 26, so it did nothing different. Well, that's because it sees an integer and an integer in our value in our 3, and it decides it's going to do integer logic or integer division and then store that in a double. So we still lose the decimal portion. Okay, well, that's kind of confusing, but what if we do divide by 3.0? So now we've got an integer and we're saying, no, you're going to divide by 3.0, which is a double. Okay, so let's go ahead and run there. I'm going to hit F5. F5 runs and it will run to the breakpoint. And let's skip over. Okay, now we've got 26.666. And so you've got to be careful when you're doing division with integers, because if you're not careful, you'll end up doing integer math and you'll lose some of the data. It won't cause an error, you'll just won't know. Okay, so you've got to be careful with that. Now, if we were to come back here, the other option we could have done is, let's get rid of this. We could say double. If we change value to double, so we changed those 3 to be double, and now we're going to run. You can hit the arrow or hit F5. So we have an integer 80, but it's stored in a double, okay? And we're dividing by 3. It does, because this is defined as a double, even though it's an integer, it knows, okay, we're doing double-based math, even though this one is an integer. So you'll get the value. So even though we started off with 2 integers, we ended up with the value we want. So it's probably best, if you're doing mathematics, to define as early as possible the data type that you want to end up with. Okay, so that defines some basic, multiplication and division. And we can also do double value D4, and we're going to say value 2 plus value. So value is going to be 80, value 2 is going to be 40, so we should end up with 120. Let's run that. We're going to step over. Okay, so now we've got 120. We can also likewise do value 4, double value 4, D5 equals value, and you can see it basically sees that we're typing, and as it recognizes a variable, we can then pick that from the list, and we're going to say we want to minus 50. 120 minus 50 should be 70. So let's double check that. F10 to step over, and so we get the value of 70. Okay, so that shows you addition, subtraction, multiplication, and division, some additional tools as we were debugging, and then the assistance that Visual Studio does. It's trying to guess what we're trying to type. So like if we want to redefine value, okay, so I want D5, and we're going to redefine value, and we're going to say that equals, say we want to do value D4 times 2. So it's trying to help with prediction and try to guess what value we're trying to get to. Those are useful tools. The IDE, or Integrated Development Environment, try to help a developer code faster. And a text editor wouldn't necessarily do that. The final topic in this lesson is on arrays. Arrays allow a programmer to store multiple values using a single variable. For instance, a programmer might want to define 24 double values to store the hourly average temperature for the period of a day. Arrays are defined like a variable with the name, type, and value, but also add the number of values to be stored. Arrays can be defined for any of the data types that we have discussed. In C#, the elements of an array start with 0 and go to the defined number minus 1. So, in our example of tracking 24 hours in a day, we would start from 0 and go to 23. This example is of a single dimension array. It has a single set of 24 values. Multiple dimension arrays are also possible. If the programmer wanted to expand the storage of temperature for a full week, they could define a 2-dimensional array with the first dimension being the day of the week, 0 to 6, and the second dimension being the hour of the day, 0 to 23. Let's take a look at how to use both of these types of arrays in Visual Studio. Let's go ahead, and I'm going to comment out this block of code. And I'm going to just go hit the comment block. All right, so now we're going to talk about arrays. And arrays are a data structure for storing multiple values. So let's start with an integer array. Int square brackets define an array. Int, so let's do hours equals and new. And it says, okay, I know this is an array, and we're going to say 24. Okay, so we're going to store the hours of a day in this. Now, so if we say hours, and then the arrays start with 0, and in this case, it'll go to 23. And so we can say, okay, hour 0 is 1. Okay, that's confusing. It's just the way Visual Studio or C# works. We're going to say 23 equals 24. Okay, so we've skipped a few, and I can put a comment dot, dot, dot. Now, let's see what happens if we violate that. So let's say 24 equals 25. Okay, so let's put a breakpoint right here in our definition of our integer array with 24 elements. And if we hit F5 or hit your start, if you notice down here in our locals, our array is defined. The second element is set to 2. Okay, so now we go down to 23 and it's set to a value of 24. And now it tells us, okay, the index was outside the bounds of the array because we only defined 24 elements and this is the 25th element. Now, the compiler didn't catch this. So this error we only found when we debugged. So the compiler isn't able to realize you're trying to hit an element in the array that doesn't exist. We only found this at runtime. So this is a runtime error as opposed to a compile time error that we saw before. If for some reason you wanted to do that, you could up the size of the array to 25. And now the array will go from 0 to 24. So let's go ahead and we've got hit F5. And so that takes us to the first breakpoint, and we can hit F5 again, and that'll take us to the second breakpoint. We could have also hit continue. So now it's happy. And if we look at our array, we now can see that element 24, so element 0 to 24, has a value of 25. So I'm going to go ahead and stop that. I'm going to put this back to 24, and I'm going to get rid of this line of code. Now, let's define a double array. So double, square bracket, temperatures equal new double 24. Okay. And so now temperatures, we're going to set the temperatures for the day. So let's say it starts at 70, and I'm going to go ahead and 70.0. 71 equals, say, it gets a little, I don't know why it's getting warmer at night, but whatever. And then we're going to set temperatures. Let's set at so 0 to 11. 11 would be 12 o'clock. And let's go ahead up here. Hours 11 equals 12 o'clock. Okay, so now we're going to be up at our 90. Say that's the hottest part of the day. And then temperatures 12. Say 80 drops a little down, whatever. And we can make these any decimal value that we want, just to show you how that works. And so we've still got our breakpoint at the end. I am going to move it to right here. That goes through. And if we look at our temperatures, we can see 70, 72, 90, and 89.5. That shows you an integer array, a double array. We can go ahead and stop this code. We can also create Boolean arrays. Is hot equal new bool, and then we can do 24. Great. Is hot, and we're going to say it's hot if it's above 85. We can say 0. Okay, we're not hot here. False. Is hot. And then we go 1. We're still not hot. Now, what we can also do is, as you get better with editing, you can copy and you can paste that. And then we can go set value 11 and 12. But these are both above 85, so that's going to be true. And this is going to be true. Let's run that, and I'm going to move this breakpoint down to here. And then we'll hit F5. And you can see that these arrays, the early arrays, are still being populated. Just because we've skipped that code doesn't mean it hasn't executed. But our isHot array hasn't been defined, so we're going to define that now. And we're going to set the 4 values. And so we can see false, false. Okay, and you also notice false is the default. So only 11 and 12 has been set true. When we initialize the array, it set all the others to false. And that's also true in this array. Hours is set to its default, and an integer's default is 0, and a double's default is also 0. Let's do a string array. A string, 2 brackets, we'll do description equals new string, and 24 here. Description, bracket, 0 equals nice. So you use double quotes to define a string. And then we're going to copy this line of code. We'll do 4. We'll do the same values. 11. And 1 and 2. And it's a too hot. Too hot. That defines those. Let's go ahead and run that. And if we notice right now, the description array is null. And what null means is it has not been defined. When we initialize that, we can then see the values in the string array are also null. So how is this different than with an integer? Well, an integer is a value type, and so it always has a value. A string is really an object, and we'll come back to objects as we go on, but in this case, null means undefined. Okay, and so until we give a string a value, it is undefined. Now we've set those 4 values. Let's define string A. Say we want to get a value out of that description. Let's say we want to go for a value that hasn't been defined. So let's take off this breakpoint, and we're going to just run to this last breakpoint. So if you notice, string A is null. If we do this again with an 11, we should get too hot. All right, so that's too hot. Now, let's go back to 10, and let me show you what happens. So a.length. Okay, so strings have some properties on them, and we're going to come back to properties in a lesson on properties. We're going to assign, say we want the length of a string. So if we go int length, so we've defined a variable called length, and we're going to store strings that we've pulled out of the array's length. Let's go ahead and run to this point. We step over, our string has a value of null, so it's undefined. Now, if we try to run this, we had a runtime exception where we cannot call a method on an undefined object. And we'll come back to more of that. Just be aware that if you try to use an array element with strings, you can run into problem if they haven't been defined. Let's try this again because we know we've defined 11. Let's run to that point. Got a value, A has a value, so it's defined as too hot. Now we can get the length, it's 7 characters. Okay, so the key around this is if we had defined all 24 values, we wouldn't have run into this error. So we didn't really properly initialize our array. And we'll come back to how to do that when we go into loop structures, how to quickly set those up. So we've gone through our integer arrays, our double arrays, our Boolean arrays, and our string arrays. Okay, great. Well, we also mentioned you can define 2-dimensional arrays. So say we want to define a double array, and we're going to do 2 dimensions, one for the day of the week, and the second for the hour of the day. And we're going to define week of temperatures equals new double, and we're going to do 7. So the first dimension of the array will be the day of the week, and we'll call 0 Monday, and then 24 hours of the day. And so what it would be useful here is dimension 1 is day of week, 0 equals Monday. So that makes 7 equals Sunday. Okay. So that's useful comment to put there because it's not necessarily intuitive to the programmer. What day are we talking about? Okay. And so that's defined the two-dimensional array. We're not going to fill this in fully, just like we haven't before, but let's say, so we're going to say Monday, hour 0. And we're going to say that's 70.2. Sorry. I used double, not the variable. So I've copied week of hours, element 0, 0, which is Monday at hour 0, and that's got a temperature of 72. Now let's set Tuesday, week of temperatures. So Tuesday would be 1, and hour 0 equals 71.2, whatever. Week of temperatures, and we'll go jump forward to Sunday at hour 0, and that equals 69.2, whatever. Okay, got some little syntax errors here. Put a semicolon at the end. Okay, and let's say we want to fill in noon, which would on Sunday, which would be hour 11 equals 90.5. Let's go ahead and run to this. I'm going to get rid of this breakpoint and put one here. All right. And so I'll run down. So we had an error because I picked 7. Well, it's 0 to 6 is Sunday. Even when you know what you're doing, you run into the problems. You've got to remember it's 0 to the count minus 1. Okay, so let's try that again. And again, that was a runtime error as opposed to a compile time error. That worked this time. If we look at our array, you can see on Monday, 0, 0, there's our 72. There's our Tuesday. We scroll all the way down to 6. Okay, there's our Sunday, hour 0, and there's our Sunday, hour 11, or 12 o'clock. So that's how you can define a two-dimensional array. And you can do two-dimensional arrays. We could do the same thing, and we're not going to go into filling them in, but you can do an integer array, test, and equals new, int, and we'll just do the same size, 7, 24. And what we could do is hour. We could do something hours of day. I mean, however you want. You can still do your Boolean is hot. We can call it weekly is hot equal. All right, we still need our brackets. It's hot equals new bool. There we go. Oops, I got to give it some dimensions. We're going to say 7 and 24. Okay, and you can still do your string. And we're going to just weekly description equals new string 7, 24. Those are all valid. And just to be, we've talked single dimension, two dimension. There's nothing that, would forbid you from doing a 3-dimensional array. You can do, so you can go crazy. The problem as you go higher, 3 dimensions, you can keep track of a cube. 4 dimension is a set of cubes. It gets harder to visualize what you're building. There's nothing that keeps you from doing that. So I want to show you a string array for days of week. 7 days in the week, and we have to say, you notice in all of these arrays where we can just define a variable, if we go back up here, equals 10, when it's an object and an array is really an object, you have to say new. In all of those cases, when we were defining an array, we said, basically type of array, variable name equals new. So that tells it create this object, which is a string with 7 elements, string array with 7 elements. So we've defined that. And so one way we could do this is to say, okay, we're starting with 0 is Monday, and set to element 0. And then days of week, 6 equals Sunday. ... we would fill in that code. What I want to show you now is another way we can define this. And so if we get rid of this, the number 7, and we can then put a curly brace, and we need a semicolon down here. So what this is this is another way of initializing an array. And so what we can do here is say Monday, Tuesday, and Wednesday. I'm going to just start making them shorter. Thursday, Friday, and Saturday. It doesn't matter. And so 1, 2, 3, 4, 5, 6, 7. So what the compiler is going to do is it derives these. The array is 7 elements from basically how many we define here. And so let's run this, and we're going to just run to the end. We've got lots of variables down here, but basically we're looking for days of week is at the end. And you'll notice that the string 7, okay, so that's an array of 7, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. This is another way of defining and initializing an array. And you can do this with integers. So if we wanted to do now, and what I'm going to do is because there's so much noise, I'm going to just go ahead and comment this block out. And now let's go down to int. We're going to do the same thing. Day equals new int. And what we're going to do is that. And then we're going to just do 1, 2, 3, 4, 3, 5, 6. Okay, so, and a semicolon at the end. So this will initialize the integer array, and you can see it's now 7 and 0 through 6 are stored. So that's another way you can do that. Now you notice here, and we talked about semicolons being at the end of the line. The semicolon tells it where to stop. So all of this space isn't, oops. I'm going to condense all of this. So basically, you can control how you use your white space, and we'll just restart that, and you can see that it does the same things. And that's true for the string array, or any of them can be defined how you want. So that can work either way, and you'll notice that the values are still the same. So the semicolon is what's important. You can condense this all to one line of code. I like keeping things broken out just so you can visualize and understand the code faster. But it is a personal preference. Typically, I adopt, when I go into a new team, I'll adopt whatever standard they've set. And you get good as you move around, doing your own code. You may have a style, but then you go to work and you do the style that's there. This wraps up our 3rd lesson. In our 4th lesson, we will take a look at conditional data structures.